Good evening, ladies and gentlemen. Welcome back to the Burkowski household. And again, I'd like to thank my lovely wife for actually doing the filming. So we are now going to be covering magnetism. So basically what we're going to be talking about this evening are magnetic fields, also known as magnetic lines of force. We're going to tie that right into Earth's magnetism itself, and then a little bit of biomagnetism. And then we're going to have some fun with some magnets and some electromagnets. So let's start with magnetic lines of force. All magnets actually create this, I guess, invisible force field. And the basically lines of force tend to gather at the poles and tend to be more wider at the center of the magnet itself. So I'm going to actually show you an example of that right now. So I'm going to actually show you a couple examples. The first one, in this little box is iron filings. And you can see if I go up and down, you can see how they're kind of falling a little bit pretty freely. Okay, so if I shake them up and have it out there, I'm going to place it down on the table, and I'm going to have my wife look down at the object. I'm going to place this magnet, and you could see now like magnetic lines of force. You could see how all these iron filings have gathered at the poles, and you could see the lines of force that has been created by this particular magnet. So those are the magnetic lines of force, or the magnetic field that is actually created by magnets. Now, there are different types of magnets. There are bar magnets like this. Okay, so I'm going to actually move this out of the way. You have, this is also a bar magnet where you have a north and a south pole. And if you recall, a couple of chapters ago, we talked about dipoles, like water was a dipole. Well, this is a dipole. It's a magnet. You have a pole on either side. Okay? We also have horseshoe magnets, which amazingly enough look like a horseshoe. And you have your North Pole and your South Pole, but they're gathered in a little bit different format. So the lines of force actually gather right here as opposed to on either end. Okay? And I want to go back to this for just a second. This is kind of cool. This is actually known as a cow pill. For those of you that are familiar with cows, they may be tasty, but they are not the sharpest animals on the planet. They'll pretty much eat anything that's in front of them. So what farmers will do when they build barbed wire fences around their property, and some of those barbed wire fall to the ground, unfortunately the cow would eat it. Now, if you are not aware, cows have multiple stomachs. And so the food passes from one stomach to the next. And if there's barbed wire in their stomachs, it will actually just start shredding them from the inside. They give the cow this, which it will eat it because it'll eat anything. And what this does is it actually attracts the barbed wire. And then when it poops, it actually takes the barbed wire with it. So it actually is protection for the cow. So this is actually known as a cow pill, but it's one of your strongest magnets out there. Okay? So those are magnetic lines of force, or the magnetic field. Okay, so the last thing I want to show you guys with lines of force or magnetism before we move on to Earth's magnetism is a 3D view of what you just saw. So what I'm going to show you is I'm going to shake it all up, and my wife is going to pan the camera down, and you can see that the filings are just kind of all over the place. Now, what I'm going to do is I'm going to add this magnet in there, and I'm going to slide it in, and slowly you will actually start to see the lines of force forming around it. So now you get a really good view. You can see that it's clustering at the North Pole and the South Pole, and you can even see more filings are coming up, and it's following these lines of force. So you see the curvature here, you see some curvature here, and you could really see that these magnets basically create this force field around it, again, where everything collects at the poles and moves around in these kind of half C's. Now, to be honest with you, the lines of force goes through the magnet itself. It really does. You can't see that because of the filings, because the filing can't penetrate the magnet, but the lines of force actually go right through and could create these continuous circles. Okay? Now, I'm going to stick one more in there just to have some fun. I'm going to actually put the same polarity, so it's going to push it away. Oh, let me find a little hole. There we go. And you can see how the lines kind of reform with two magnets, and then I'll do it with the opposites, so they will stick together, and then you could again see kind of where everything starts to cluster on the edges, and so it creates some different things. So basically, those are magnetic lines of force. Okay? Now, what I would now like to talk to you about is Earth. Okay, so this is my wonderful drawing of Earth, and I'm going to add where we have the North Pole approximately and where we have the South Pole approximately. Now, I'm going to put this down for just a second because I'm going to add something to it, and I want you to see that the lines of magnetic force do not line with the actual poles themselves. Now, bear in mind, I'm not the greatest artist, but you could see the lines of force actually, the North Pole is somewhere kind of by Canada, actually a little ways away from where the true north is, and South Pole is actually somewhere kind of below Australia. So these lines of force, so everything collects kind of by the poles as far as the force. So Earth itself is a magnet. Now, to be honest with you, scientists are not completely sure as to why. The best guess is two reasons. One, the way the Earth rotates, as well as what you call convection currents. You have constantly new lava being brought up from the molten part of Earth, and electrons, basically energy, is being brought up. And so it creates these lines of force. And it's like having a bar magnet running right across Earth. But what's, again, nobody knows for sure, but they believe it's the rotation of Earth as well as the magnetic lines of force. Now, they've also shown that over time, the polarity has reversed. It's reduced to nothing, so no magnetic field at all, and then it's reversed and switched, and so south becomes north. Now, the last time this happened was hundreds of thousands of years ago, but it has happened periodically in Earth's existence, okay? The other thing I want you to understand, too, is the sun is constantly sending out what's called solar wind, which is the charged ionic particles, and they come flying through the atmosphere, and they hit the magnetic fields, and they start moving along the lines of magnetic fields. They never cross the lines, but they move along, and they start to cluster at either pole. And periodically, if you have enough of a solar wind, you end up getting the aurora borealis and the aurora australis, which is the northern and southern lights. So that's also created by these electromagnetic fields of energy coming in and hitting Earth's magnetic field. So Earth actually is a magnet. And what it does, it protects us from all that solar radiation coming in. Now, not completely, but it does protect us. So that is Earth's magnetism. Now, the last thing I want to talk to you about before we have some fun with magnets is biomagnetism. Now, the word bio means life. Magnetism obviously refers to magnetism, obviously. So there are lots of actually creatures on this planet that use the magnetism of Earth to guide them. There are these bacteria that live in both the northern oceans and the southern oceans, and they have these single pole magnets that are forming in their bodies. Really neat. It's magnetite actually is the chemical, which is very similar to magnetism, to a bar magnet. And so when they align in their body, they actually know how to use the magnetic lines of force to find food, actually. The same bacteria in the southern hemisphere actually have the oppositely poled magnets, so they can actually move towards the equator. So it's interesting, same creatures, two different spots on the Earth, but the magnetism is aligned differently in their bodies. One that you may have also heard of is the carrier pigeon. The carrier pigeon has magnetite in its brain, and it uses the magnetic lines of force to actually travel to different places. And that's why people use pigeons to actually bring packages, because they know that they would actually get from one place to the other. They don't get very disoriented. There are a lot of creatures actually. There's even studies that show that we have magnetite in our brains too. Do we have magnetism in our brains? Do we actually work with the magnetic poles, which is very interesting. So those are ongoing studies. So that's what biomagnetism is, using Earth's magnetism, and living creatures actually develop these magnetic properties within their bodies to actually work with magnetism. So now we get to have fun with magnets and electromagnets. Be right back. All right, so ladies and gentlemen, we're about to have some fun with some magnets, but I just want to go back to one thing to understand all this. The magnetic fields, or the lines of force that are created by magnets, allow us to do all the kind of fun things I'm going to show you, but also I want you to understand there are some really practical applications in terms of understanding the electric field potential difference, understanding the magnetic field and how all that works, and some of the most brilliant minds have used those concepts and have created some of the most amazing things. Tesla actually had a drawing or had a write-up on the very first cell phone. We'll talk more about Tesla actually next week. Faraday, there's Marconi. There's so many scientists that use the concepts of electricity and magnetism and how they work together. Computers, TVs, cell phones, ice makers, toaster ovens, electric can openers. I can't even begin to tell you how many conveniences we have are all based on these simple concepts that you've been learning in these last few chapters. So let me go back and just kind of show you a couple things. So magnets create a field of electricity, field of magnetism, of course, that is kind of invisible, but when you use iron filings and you use a magnet, you could see the field that is created around it. You could see the curves, you could see where it collects at the poles, and you could see the lines of force in a sense. You can kind of see them a little bit more clearly here, a little bit more clearly here, okay? And then because of that itself, you could just have some fun. You can make the stuff dance, and you can just have some fun. Magnets have always been one of those things that have just attracted everybody because of the fun you can have with them. I kind of always, as a kid, pinball was very big when I was growing up. Arcade games were very big. And I always wanted to take a big old magnet and kind of move the pinball around and get a higher score. But for those of you who understand pinball, you know what I'm talking about. For those of you who don't, I'm sorry. So, again, you can see it from a 3D perspective when we use this one, okay? And we'll put this little cow pill in there. And you can see the magnetic lines of force. Yeah, that looks really cool. But then you could even take other magnets and just, again, have some fun. So we could take one that's one pole and we'll push it. Oh, that's pushing it away. So you could obviously push things away. You put it here, and then we would obviously want to flip this one like this to make it connect. And you can just have some fun. You can move the stuff around, and you can just... So magnetism is kind of cool. So that's just the basics of what I want to show you. Now I'm going to show you some fun, other cool little things one at a time. Okay? All right. So, ladies and gentlemen, using simply the properties of opposites attract and similarities repel, you can, again, use this invisible field, this visible, basically, lines of force to kind of have some fun. So I could just take one magnet and just kind of move it around and make it spin, okay? I can flip it around. I can go the other way, okay? You can make it reverse. You can do all kinds of cool things like that. You could put the two of them together, and you can get, if you get one to spin, the other will start to spin, okay? And so, again, I'm clearly not touching this, so it must be magic. In fact, honestly, guys, a lot of magic is done with magnetism because you clearly can't see it, so it must be some kind of magic that's making it happen, okay? So that's a simple kind of cool thing you can actually do with magnets, and you can have all kinds of fun. Again, magnets are just super cool. All right, so ladies and gentlemen, what you're actually looking at is a compass. Now, what a compass simply is a bar magnet that I showed you earlier. If you take it hanging from a string, and it just basically aligns itself to Earth's polarity. So you can see the red, by me moving, these are not the best compasses, by the way, but the red needle is actually pointing, now it's moving a little bit because I have a magnet in my hand, but the red needle actually is pointing magnetic north. I'm going to have my wife pan up to me, and I'm just going to show you a drawing that I showed you earlier of Earth, okay? And so remember, Earth is a magnet, and so true north is kind of over here. Magnetic north is here. Okay, now again, this is not the best drawing, but you get the idea. So the compass is actually not pointing true north, it's pointing towards magnetic north. Now, one of the cool things you could do with a magnet and a compass is you could do whatever you want. You can mess it up completely. So I'm going to have her pan back over, and I'm just going to take the magnet, and I can just change the polarity and move it around. Ooh, a little friend of mine wanted to say hello. Anyway, so you could that's another fun thing you could do because the properties of a compass, really, it's another magnet. So you're taking two magnets and you're just messing with each other, just kind of what I did earlier, but this is set in a format where it's based on north, east, west, and south in direction. And that's what a compass is. It's just, again, based on the magnetic field of Earth. All right, ladies and gentlemen, I think we're going to have a visitor for the remainder of the video. You've already met Charlie. This is actually Charlotte, so she's probably going to kick it with us. So anyway, I want to show you something kind of cool. Electricity and magnetism, I told you, have a relationship with each other. What also scientists have figured out for quite a while now, which obviously allows us to have all these, allows us to have all of these appliances and things, and conveniences, I should say, is there is a way you can take electricity and induce magnetism, and vice versa. And I'm going to show you how you could take electricity and make something into a magnet. Now, we have an ordinary paper clip. Bam. And I will place that down. My wife will focus on all the stuff in just a few minutes. Okay. We have ourselves an ordinary iron nail. I'll place that right there as well. We have a copper wire. I will place that with some coils already set up. And I have a 9-volt battery. A 9-volt battery is simply just a number of 1.5 volt cells. A 6-volt battery is the same thing. So a D cell, A, AAA, those are all 1.5 volt batteries. And so they're generally in combinations of 1.5. So 1.5 plus 1.5 is 3. So you'd have 4, 1.5. Okay, Charlotte, thank you for doing that. Okay. Sorry, guys. So a 9 volt battery would have 6, whatever. So that's how it's set up in batteries. Anyway, so now I'm going to take these ordinary items and turn this nail into a magnet. Now, I could touch it all I want. It's not picking up this paper clip. It's not. It's not. And I'll show you that a magnet would pick it up. I'll grab any magnet that I have. That's not a very good magnet, to be honest with you. That's kind of funny. I'll grab a much better magnet. And you can see it'll pick it up, right? So you saw the nail cannot pick it up. It's just a nail, okay? But if I put coils of wire around the nail and I attach both leads, remember we talked about leads, to the 9 volt battery. So now we have a closed circuit and we have electricity running through. And let me just get so I can make it as easy as possible because it's not the easiest setup, but everything is touching. And now I'm going to touch the magnet or this electromagnet to the paper clip and it picks it up. And so what I have created is an electromagnet. So I used electricity to create an iron nail into a magnet, but it's only temporary, only if the electricity is actually running by it to create this electromagnetic field. So I'm going to put it back down and I am going to take it out and it doesn't work anymore. All right, so ladies and gentlemen, the last thing I'm going to show you is a simple electric motor or electromagnetic motor. Okay, and so the first thing I'm going to use, I need a power source. And so I'm using a 1.5 volt D-cell battery. And like I told you earlier, most batteries are based on a combination of 1.5 volt batteries. Okay, now what I did is I took 2 paper clips, okay, and I kind of opened them up and I electrical taped them to the positive and negative side of a battery, or the, the flat side and the bump side, basically. Okay, so it is basically most of a circuit. Now it's still open because there's nothing connecting it. So there's my power source. Now, to connect and close the circuit, I have a little coil of magnetic wire. So this is 22 gauge magnetic wire. Remember, gauge is the thickness. And I wrapped it around the battery, and then I created this coil. And if you look really closely, you might be able to see some of the coils where I wrapped it around on either end to make it kind of flat, okay? And if you could tell, this coil in the middle is much shinier than what's on the outside because I took sandpaper and I shaved all the coating off because I needed to have contact with the metal paper clips on the battery. Now, when I actually place this on the battery terminals, or the extension of the battery terminals with the paper clips, all I've done is close a circuit. I haven't created anything. And there'll be 1.5 volts of electricity flowing through this circuit, right? So I'll do that now slowly, and I'll place it on there. Okay, and just kidding. It's only 1.5 volts. It's not a big deal. And I'll place it in there. Now, it's not going to do anything. It might sway back and forth because you want the flexibility. I can spin it all I want. It'll spin, but it'll stop because nothing is creating this flow to allow it to spin. Now, what a motor actually is, guys, it's something that takes power and turns it into motion. That's what a motor does. A generator is actually the opposite. It takes motion and turns into power, but we'll talk about that actually next week. So I'm missing something, and what I'm missing is a magnet. Now, this is not the ideal magnet. This is a strong magnet, but it's not the ideal magnet because you really want one of those flatter magnets, almost like a refrigerator magnet, but strong ones, to place right here. So it basically, this is a little bit too tall, but I don't have one of those. But if I place it in the right spot, you can see it's starting to wiggle a little bit, and we're going to get it to spin in just a minute. So once it's all together, you can see that it actually causes a magnetic field and causes rotation. And sometimes if it's off a little bit, it will actually stop. And you can see how the magnetic field is actually trying to work, and then it resets again. And now you have your electric motor. Okay? All right, so let me just wrap this up, ladies and gentlemen. We talked about magnetic fields and lines of force. I showed you with the iron filings, both in a 3D and a flat version, how you have these invisible lines of force. Earth is a magnet and creates its own magnetic field, which does actually protect us from cosmic radiation and things of that nature. We talked about a little bit how creatures on this planet use magnetism, magnetite in their bodies, which is a bio version per se of magnets itself, and that allows them to use Earth's magnetism to survive in life and do different things such as that and that nature. Excuse me. So, and then the last thing we did is we just had some fun. Remember, there are some amazing things that we think of, that we live with every day. Look around your house, and you'll be blown away. Without electromagnetism, we wouldn't have 90% of the things that we actually have, which is kind of super cool. So on that note, you have a wonderful evening, and we'll see you next week. Bye-bye.